Hello everyone, this is Gabriel. In this tutorial, we're going to be learning simple linear regression using the Python programming language. The first step is to import the package numpy and the class linear regression from the sklearn package. So let's do that now. Import numpy as np, then sklearn dot linear model import. So from sklearn dot linear model, we import what? Linear regression. So let's run our code. For us to run it, we use the Alt and the Enter key because this is a Jupyter notebook. Now we have all the functionalities we need to implement a linear regression. Now let's provide a data set for ourselves. Let's say x np.array. Just want to create simple data for explain this. Let's say 5, 15, 25, 35, 45, and 55. Then we ship. So y equals to np.array 5, 20, 14, 32, 22, 38. Now, let me explain this code. We have two arrays. This is the input x and the output y. Now, we should call reshape on x because it requires two dimensions. So this reshape minus 1 and 1 means two dimensions. That's exactly what this argument specifies. Now let's print it and see what we are talking about here. Can you see x? Then let's print our y. Can you see? The x is going as a vertical, then y is going horizontally. Now let's create a model and fit it. So press model equals linear regression. Now this statement here, it will create the variable model, like this variable here, model, as the instance of linear regression. Now it's time to use the model. It's time to start using the model. First, we need to fit on this model here. So model dot fit x and y. You can as well write this 2 this way. This is almost the same thing. Linear regression dot fit. So it's the same thing. Now let's say we want to obtain coefficient of determination. This is also the same as r squared. So to do this, create a variable rsq. You can name the variable anything we want, but here I'll be using rsq as my variable name. Then model, it is this model we created here. It is this variable we created here, which is called model dot score. That's the function then, x and y. So we want to print what? Coefficient of determination. And we call this what variable here RSQ, R underscore SQ, and we run our code. So that means for this data set x and y, our coefficient of determination, which is also referred to as R squared, is what? 0.715. Can you see that? You can also get the intercept and the slope for this data set, which is also called beta naught and beta 1 in class. So beta 1 and beta 1. We want to print what? Intercept. Also referred to as beta naught and beta 1. Intercept. So model.intercept underscore. That's the function. Then I want to print the slope. Model dot coef underscore. Close our parentheses. Can you see that? These are our intercept and our slope. Now, this slope here is our beta naught. This intercept here is our beta naught rather. Intercept is our beta naught, which is what? 5.63. It illustrates that your model predicts the response 5.60 when x is equals 0. This beta naught here, which is the intercept, 5.63, it illustrates that your model predicts the response 5.63 when x is 0. Then the value beta 1 here, that is the slope, 0.54. It means that the predicted response rises by 0.54 when x is increased by 1. Now, let's predict our response now. Create a new variable y underscore pred. So model dot predict. Want to predict x. So create a variable y underscore pred equals to model. This model here dot predict. This is the function dot predict x. So want the output to be like this: print predicted response. Predicted response. Let's run our code using the Alt Enter key. Can you see? These are the predicted response for x. Thank you.